Welcome to Spring LIB.
So with this problem, there's a really key thing here, which is that the metal chloride formula is MCl3, and we are actually reducing that to just solid M. So that means that we must be using, there must be 3 moles of electrons for every 1 mole of M, because we're going from M3 plus to M0. And so what we can do now is just go right into this problem, because we're given a time and we're given a current. From there, we can get the charge. We can use Faraday's constant to determine the moles of electrons that produce that charge. Now we have moles of electrons. We can use our mole ratio, which is given up here, the 3 moles of electrons per 1 mole of metal. That will give us the moles of MCl3. From there, if we know the moles of MCl3, and we say there's a 1-to-1 ratio of M to MCl3, that means that the moles of MCl3 is going to equal the moles of M. And now we can use the mass of M that's given in the problem to calculate the molar mass. Having the molar mass, we now know the identity of the metal from the periodic table. So we get right into this. It's 1397 seconds. It's 6.5 amps, which is 6.5 coulombs per second. Using Faraday's constant, cancel out the charge. Now we need to go, this gives us the moles of electrons. Now we need to convert this into moles of MCl3. There's that 1-to-1 ratio of moles of MCl3 to moles of metal. And so that gives us 0.0314 moles of metal. Now a molar mass is the mass in grams divided by the number of moles. We're given the grams in the problem. It's 1.41 grams. Divide that by 0.0314 moles. That gives us 44.9 grams per mole. Now you want to be careful with rounding, because you're looking up the values on the periodic table. So if your answer is a little bit off, you may be unsure what metal it is. So you want to, if you try to put this in your calculator, you really want to keep this number unrounded if you can store it in your calculator, because I actually originally got 44.1 and I ended up redoing it and getting 44.9, and that's exactly what's on the periodic table for scandium.